Algebra I 11.3b, Simplifying Radical Expressions. And the product property for radicals says for non-negative a and b, if we've got the square root of a times b, then it's going to equal the square root of a times the square root of b. We can split them up, see? And this property is going to help us simplify radical expressions. We'll know the radical expression has been simplified when its radicand, the number under the radical symbol, doesn't have any perfect square factors anymore. And we find the root of the large number by finding the roots of the factors. If we put the factors into two groups, perfect squares and not perfect squares, we can simplify it, and we use that largest perfect square. We're going to assume that all the radicands are non-negative from now on. They're going to be positives or zero, because many formulas and problems for radical notation, the variables don't represent negative numbers. So take a look at this one. We've got to simplify the square root of 18. Well, we factor the 18, and the perfect square would be 9, and 9 times 2 is 18, isn't it? So now we need to split this 9 up, don't we, to get the square root of it? Well, that'll be a 3 times 3. So that's a nice pair. We pull out one of the pair and put it in the front, and we've got 3 square root of 2, see? See how we've got the 3 and then the root 2? So the 2 is going to stay inside the radical symbol because it's not part of a pair. It's not a perfect square. It's actually an irrational number, isn't it? And the decimal place keeps going and going and going. So we're just going to leave them inside the radical symbol and put the 3 on the outside. See? Take a look at this one. We've got the square root of 15. Well, the factors for 15 are 3 and 5, 1 and 15, and there's no perfect square factors, so it can't be simplified. It's finished. It's done. It can't be done. Take a look at this one. To simplify the square root of 48a, well, a is by itself. It's not squared, is it? So we're only going to have one of them. So we need to pull out some perfect square factors. And 16 times 3 is 48, so we can say the square root of 16 times 3a. Now we can rewrite with the product property for radicals, and we get the square root of 16 times the square root of 3a. And the square root of 16 is 4 times 4, right? The square root of 16 is 4. So we put the 4 out in front, and we write a radical symbol with the 3a inside because that's not a perfect square. See? For the square root of 72x squared, we've got a perfect square would be 36 that we could pull out of it. And we've got this x squared, so we've got the square root of 36x squared times 2. We can rewrite this using the product property for radicals as the square root of 36x squared times square root of 2. And this would end up being 6 times 6, wouldn't it? So the square root would be 6 and x, because we would just take one of the x's, wouldn't we? So now we've got 6x root 2. See that? Now we've got this big polynomial. Look at this. We've got the square root of 3x squared plus 6x plus 3. We can factor this as 3 times x squared plus 2x plus 1. We can pull them apart as the square root of 3 times the square root of x squared plus 2x plus 1. We can rewrite using the product property for radicals, and we can rewrite this one as x plus 1 squared, couldn't we? Because if we unfoiled it, it would come out like that, wouldn't it? So now we've got the square root of 3 and x plus 1 on the outside of the square root symbol. See that? We don't include it underneath the vinculum, okay? I think we talked about this back in 8th grade, I'm not sure, but the radical sign is actually the check mark part of it, and that's called the vinculum, okay? So the x plus 1 does not go underneath that vinculum, okay? All right, to take a square root of a power like x to the 8th power, the exponent has to be even. So if we've got x to the 8th, we can split it into x to the 4th times x to the 4th, because the product rule of exponents says we add the exponents, right? So we'd have 4 plus 4. So that's very easy when it's even to square it and split it in half. See that? So if we want to simplify the square root of x to the 6th power, we just do x times 3 times x times 3, x to the 3rd times x to the 3rd, see? We could also write it like this, x to the 3rd squared. We just take one of them as the answer, x to the 3rd, see? If we've got square root of a to the 10th, we split that 10 in half to a 5 and a 5, or we can say a to the 5th power squared, and a to the 5th is the answer, see? When there's odd powers, we write the power as a product of the largest even power and x. And then we simplify the even power. So if we've got x to the 9th, square root of x to the 9th, we pull out the largest even one, 8. That's the largest even one from 9. And we've got the square root of x to the 8th times x, because there's a little invisible 1 there, isn't there? That would give us that 9. Now we can split the 8 up into a 4 and a 4, can't we? And because this x by itself, with no exponent, is not part of a perfect square, it's going to stay inside the radical symbol and the vinculum, and we're going to put the x to the 4th power out in front. See that? So when there's an odd one, just pull out the biggest even one and have that spare leftover one by itself underneath the radical sign. See? If we've got something like this, all we have to do is break this into a 6 and a 6, right? Should be. Right? So we just take one of them as our answer. It would be a plus b to the 6th power. See? That means a to the 6th plus b to the 6th. See? And if we see something like a negative 3 outside of the square root of 72, what we do is we work on the 72, and 36 is a perfect square, and 36 times 2 would make 72. 36 would break up into a 6 and a 6, right? We take out one of those 6's, multiply it by that negative 3 out front to get negative 18, and our answer is negative 18 root 2. See that? See how I did that? So if you see something like this and it says simplify it, work on the inside first, and then when you find your perfect pair, then you multiply it to the one on the outside to get your answer. Okay? All right, our next video, 11.3c, we're going to talk about cube roots. And of course, if you want a link to any of the previous videos we've done here in Chapter 11, they'll be in the description of this video. Okay? All right, I'll see you in the next video, and we'll talk about cube roots. In cube roots, we actually put a little 3 up in the corner here. I'll see you. Bye.